Hey, is everything okay? Mm. Oh, for exchanging the greetings? Well, mm, mm, yeah, that's yeah. Mm, yeah. Okay. Well, I mean, if you hate what you're doing, it permeates. You know what I mean? So, but it's scary. It's scary to like, tell people no, tell society no, and go for what you truly want. Society doesn't want you to do that, but that's what you got to do. But being an enlightened being, it's like you got to realize she's doing the best she can too. From like, you know what I mean? Like I know if I was there, I would probably behave the same way. Let me go. Yeah. Okay. Take it. All right, guys. Let me see. I cannot hear anything. It looks like my audio is still going. Let me get everything set up. I'm trying to think what changed. Something changed. Let's go like this. Oh shoot. Come on. Okay, input. That looks good. Output. That looks good. I hope it's not this. E. Let me check one other source. Guys, I'm coming. I'm trying to figure out what happened to my audio. Hello, hello. Okay, that's working. Yeah, I can't worry about it because I can't hear anything. So I'm not gonna worry about it. Okay. Otherwise, I'd have to reboot OBS, and then that'll just like kill everything. So, okay. Let's see. We are there. Let's start off here. Okay. So welcome YouTube and students. This is Beautiful Mind here. So this is going to be the presentation. This is a week 5, day 10 on section 3.2. This is going to be a homework session, right? So to kind of recap, let's get an update of where we are. So as far as Blackboard is concerned, hopefully you guys can hear me. It'd be nice if you confirm that you can hear me. All my stuff looks like it's okay, but let me check one other thing. Yeah. Maybe that disconnected. It probably got disconnected when I got the phone call. I got to figure out how to like put this in airplane mode so it doesn't.
I can hear you.
Yeah, I can hear you.
It throws my stuff off. God, that's irritating. Let me do it like this. Maybe this will help. Oh, I was able to fix it last time. Anyway, I'm just gonna kind of trust it. Okay, I see in the chat. Let me check the chat. Sucks not being able to hear. Okay. So we have had exam 1 that was due, Sunday night going into Monday at midnight. But it's still available. You can actually improve your score. It's just a 10% late penalty on any assignment that's submitted late. Also, keep in mind we get unlimited attempts at everything. I do encourage you to link up with the tutors. You have already paid for tutoring is included in your tuition. So, if you can't get it from me, because I know how it is with me. Like, I get it. I don't know how to present it any other kind of way other than just state the facts, stick to what I know to be correct, and then just try to help as many people as I can. But I can't make you do anything. I'm just kind of acting like a referee, but whatever your experience is totally up to you. Like if you want to experience success or defeat, it has nothing to do with me. I'm just like a referee or a guide. But you have to kind of decide for yourself. And I know that, and take that with a grain of salt, But if with success, you get the glory, with defeat, I mean, I can take responsibility, but that still doesn't help you. You know what I mean? I mean, maybe it does. I don't know. But the experience is yours is what I'm getting at. So you just got to take charge of it and push. It's a challenge. I couldn't imagine doing this online. That's a lot. I'm not going to lie. That's why it's like I do the unlimited attempts. I do the only 10% late penalty. I do a lot of things on purpose, right? Hopefully with the intent to encourage you all to just take your freedom. Nobody's going to give it to you. Nobody's going to empower you. You have to take it yourself. What's going to happen? My stuff seems like it's trying. Okay, I'm gonna just let that be. Let me see. So anyway, that's that stuff. So we're going to continue with section 3.2. Using the second derivatives to find max and mins. Okay, it's still okay. Let me see. Are you doing any better? It's looking better. Okay. Oh, see, I can't connect. I can't access my honestly, everything needs to be restarted. I guess I have too much stuff open, so it's like do what I need to do. Let me see if this works, because sometimes this works if I just open this. Because as I try to access my menu bar to access the Bluetooth, I know what else I can do. Let's go like this. Yes, that's exactly what I want. It was there. It's here. I guess I have too many processes open, so it's slowed down. It's probably just time for a new laptop. This is a really old one. Yeah, it's lagging. Come on. All right, I'm gonna have to let it go. So we're in 3.2 using the second derivative. So last section, let me see. So yeah, also another thing about Blackboard that I was trying to say. So I kind of got a little bit of leeway with the grades. You should notice something that says homework average and exam average. That's going to be a running thing, right? So because it's going to be updated based on what's available and what's been due. It's just like a gauge for where you are, but it's not really determined until the very end. It can change for anybody at any moment. I've had cases where people are at the bottom going into the end and they're able to turn it around and get everything submitted. I've had people think that they're at the top, but then once I submit zeros, if you haven't submitted your assignments and I push those zeros, it's gonna change. So you want to just make sure. All right, so this isn't gonna work. You just want to make sure to get your assignment submitted. Let me check one other source. Maybe I can just force restart it. Sometimes system preferences. Let me quit that. Quit. And let's relaunch this. Hopefully that won't mess stuff up. Okay, but yeah, the main thing is once you get into my Zoom, you've gotten your attendance credit for the day, and get your assignment submitted promptly on Pearson. Okay, so and I am monitoring the chat. So if you have questions, as you have questions or anything like that as they arise, just feel free to either type it into the chat. Right now, I can't get my headphone to work. It got disconnected, I think, with the phone call. So and like if I stop it, it's just gonna mess everything up. Okay, I gotta change that. Let me check one other thing. I'm gonna try one more time. Let me see. Yeah, that's still doing that thing. This is bad. Okay, that seems like it's still working. That's fine. Then let's go here. Come on. You can do it. Let's see the time, because I know that one is not accurate either. Okay. Maybe I might have to just get a more powerful machine. All right, I'm gonna scrap this. I'm gonna just try to trust my audio is fine, because I know you guys can hear it, but it's just throwing me off. Let me see. I gotta force quit again. Either like that or like this. Force quit. Okay. So I'm just gonna kind of move forward with the practice. We're gonna hop over to Pearson. That looks good. That's still there. Okay. Hopefully, yeah, it should be good. So we're gonna go ahead and kind of look at the material. Let me see. I want to kind of start with something from section 3 too, because right now this is the review section. Are you like slowing down too? Ugh. I'm gonna take this out. Did it connect? No. All right. So again, I'm not going to be able to hear you guys right now. I just probably need another system. I need like a headphone, something or another. R2 is kind of starting to click now. I want to get to section 3.2. Okay. And I guess going forward, I guess I need to put myself in airplane mode, but I don't know how to do that and still be able to access the internet. So I figured that out. Okay, so let's look at this one, right? It says for the graph shown, identify the points of inflection. Okay, so let me just kind of make this statement about point of inflection. So some of the techniques that I'm using, I go into detail in my pre-recorded lectures, right? Because you see how when we stream, it's very easy to have like technical difficulties, right? And one little hiccup and you can like waste a whole lecture. So that's why I was like, hey, we need to do asynchronous where I can load the lectures in advance because it's too volatile. It's too like sensitive to live stream without any trouble. So that's why I make my video lectures in advance. So I'm going to do a brief recap on what do I mean by point of inflection, right? So if we look at this curve, let me see if I can make this bigger. So if we look at a curve, right? So the first derivative tells us whether the function is increasing or decreasing, right? So if we look at this function is decreasing from negative infinity up to x equals 0, right? So the derivative would be negative for any value on that left side right there. And then between 0 and what is this, 2, the first derivative will be positive because the function is going to be increasing. And then it's going to be decreasing. So the first derivative tells us whether the function is increasing. Oh, okay. I'm like, what is that smell? My dog is under me. She's doing stinky dog farts. This dog. Woo. Okay, let me check the chat. It doesn't send him the invite because he's not in my waiting room. and he should be able to join. Yeah, just send him the invite and just, you know, tell him to keep trying. But yeah, the first derivative tells us whether the original function is increasing, decreasing, or constant, right? So then the second derivative tells us the rate of change of the first derivative. In other words, what that tells us about the original is whether it's concave up or concave down, right? So if we start on the left side, the far left of this function, notice it's like a cup, right? And the cup opens upward. So the second derivative would be positive up until the point of inflection is where it goes from concave up to concave down. So the curve opens upward. The second derivative will be positive up until x equals, what is this, 1? And then it's going to be concave down on the right-hand side, right? So we would anticipate to the left of 1, it would be concave up. And then to the right of 1, the second derivative should be concave down or should be negative. All right, looking good. I'm going to let the student in. Okay. So that's a little bit of back. So the point of inflection again is where the graph is going to go from concave up to concave down. And that's going to occur where the second derivative is either 0 or undefined, right? So that being said, so actually I was about to calculate it, but this one just wants us to look at it. So the point of inflection from looking at the graph is when x is 1, y is what, 4? So this right here is the point of inflection, 1, 4 for this one. Okay, so this is just looking at the graph. We're going to see how to find this algebraically. Okay, and then the intervals, okay, so it's concave up to the left of 1. So it's concave up, or in other words, the cup opens upward from negative infinity up until 1. And then it's concave down from 1 to infinity. Okay, let's go with that. Okay, and I am monitoring the chat, so feel free to type questions. Ali Oxenfree, yeah, I think you guys can hear me. Let me see. Yeah, I'm just gonna have to trust it. I gotta figure out another system. I'll figure something out. Probably need another set of headphones. Okay, so for the following function, give the coordinates of any critical points and classify them as a relative max or min or neither, and then identify the intervals of where the function is increasing or decreasing. Give the coordinates of any points of inflection. Identify any intervals where the function is concave up, concave down, and sketch the graph. Okay, so this one is basically, to sum all that up, basically what it's saying is, look at the first derivative and analyze what it's telling you. Look at the second derivative and analyze what it's telling you, right? So we're going to take some notes. We're going to have some fun, right? Hopefully you can find this fun. I know it's a little bit intimidating, but once you see it, it's not really that bad to a degree. I mean, I don't know how safely I can say that, but it's fun. Ugh. Okay, hang on. I was just about to get into my rhythm. Got somebody else coming into the waiting room. Let me let the student in, hopefully. Let me get away from that. And this is this student, okay. All right, I'm gonna let it be. I'm gonna hit admit. And I'm gonna do my paper. We're gonna take some notes before we hop over to the tablet, right? All right. All right, let's try this again. Because I got more students coming in, so it's like I gotta, and then so like my stuff is just like, this is Mr. So-and-so. Come on, there he is. Boom, looking good. I think we got everybody. I'm not gonna worry about it. I'm gonna let him in and keep it moving. Okay. So this is question number 7 from this. Okay, this is week 5. This is week 5. This is day 10. And we're looking at section 3.2 using the second derivative. Okay. I'm gonna just use that for now. This is question number 7. This comes from section 3.2, question 25. So then part A says find any critical points. I'm gonna just say find any critical order pair, critical points. B, intervals. Let's say identify intervals where f is increasing or decreasing, okay? And then C is asking, find any points of inflection, find any points of inflection, okay, inflection. Identify intervals where the function is concave up or concave down. So then D, identify intervals where F is, I'm just gonna, I do it like a up circle or a down circle, concave up or concave down. And then E is sketch, right? So once we find these like critical values and points of inflection, we also want to find a few additional points between and beyond all these points, right? So we could find like the x-intercept, the y-intercept. Okay, let me no. So it's like what another thing that's throwing me off, like, is the handoff. It keeps trying to hand off, and it's like throwing the stuff off when I do things. Let me see, but it's okay. So we're looking good. Okay, I'll let this student in. So yeah, so points that we're going to be looking for. First, we're going to identify any critical values from the first derivative. Identify any points of inflection from the second derivative. We might investigate the y-intercept. We might investigate the x-intercept, and then we might find a few points between and beyond all those points, and then we're going to connect it with a smooth curve, right? Okay, and almost. I need one more thing. We need the function. So we have this q of x. On bottom, we have x squared plus 64, and on top, we have x, okay? So let's hop over to the tablet, and also, again, I am monitoring the chat. I can't hear you guys because just my stuff went haywire today. But I am monitoring the chat, and we're gonna kind of work with that, okay? Let me check one other thing because I just realized something else that might be going on that will mess stuff up. Let's see if that's still going. It shouldn't be because I didn't see any bars. Okay, it is muted. That's what I needed. Okay. We're gonna hop back here and let's make sure it's showing here. Looks good. Okay. Okay. I bet you there is a way to do that. Let me see if I do like this. No. What if I do like this? Nope, that's not gonna do it. Okay, I'm not gonna worry about it. Let me try this. Okay, let me stop. Okay. So yeah, these are what we're going to be doing. Again, the A is talking about the first derivative, B is talking about the second derivative, C is talking about the second derivative, D is talking about the second derivative. We're going to identify all these, and then we're going to put it all together. Okay. So let's start with A. Part A, find the critical values. So we have G. So then let's go ahead and find G prime. So let's take the derivative, right? We can use the quotient rule. I was going to rewrite it, but quotient rule shouldn't be too bad. So quotient rule goes low D high minus high D low over low low. So that's going to be the bottom, which is this, times so d by dx times the derivative of the top. Okay, so the derivative of x minus the top times d by dx, the derivative of the bottom. Okay, all over the bottom squared. Okay. So then if we evaluate, the derivative of x is 1, so then we have the x squared plus 64 persist. The derivative there, so we're going to say minus x times, let's see, the derivative of x squared is 2x, and that's it, because the derivative of 64 is a constant, so that goes to 0. Okay, all over the bottom squared. Okay. And then let's do one more. So then G prime, so that's going to be a negative 2x squared. So we're going to have, let me see, 8 times 8. Okay. Looks like we got 64 minus x squared. So it's dogs out there barking. My dog is she got to clap back. She's a little chihuahua, but she thinks she's like the biggest dog around. So she's like one of those people that be like, hey, yo, hold me back. You better be glad my friend hold me back. Because the minute she get close, she like cowers and like goes into a fetal position. She is hilarious. I mean, fortunately, she hasn't like bitten anybody. Like it's nothing like that. But she be acting all big, and then the minute she get close to somebody, she be like, "Oh my bad. I was just playing. I wasn't for it. That's how she acts. Anyway, it's hilarious. Okay, 64. That's a difference of squares, right? But it looks like nothing cancels because it's going to be 8 minus x times 8 plus x. Nothing cancels, so I'm going to leave it for now. Okay. I'm going to go ahead and write it. So this is the same as 8 minus x times 8 plus x. Okay. And we got x squared plus 64 squared. Okay. So even though nothing cancels, I just like the way it looks. Okay. So that's the first derivative. Let me see. So then part A asks us to find any critical points. So the critical points are going to occur when this fraction is either 0 or when it's undefined, right? So this fraction is going to be 0 when the numerator is 0. So if we set the numerator to 0 and solve, I'll do, I mean, they're about the same. I'll do the second one. So if we say 8 minus x times 8 plus x, if we set that to 0 and solve, we get plus or minus 8, right? X equals plus or minus 8. Both of those make the original 0. Also, the critical value is going to occur, a candidate occurs when it's undefined. And this fraction is going to be undefined when the denominator is 0. Let's see. I don't think the denominator is ever going to be 0, right? Because if we set it to 0 and solve, nothing comes out. We get like an imaginary result. So it's never going to be undefined, but it can be 0. So these are our candidates that we need to investigate. Okay, so what we're going to do now is put these on a number line. Let's try that again because that should have worked. Okay. So let's say here's -8 and here's 8, right? So these are the first two candidates for our critical values. So then we want to investigate the first derivative. We want to investigate the first derivative. So let's take a number to the left. Let's take a number over here to the left of -8. A number to the left of -8, I'm going to do -10. So hopefully that's not too big. If I plug in -10 into the first derivative, okay, this is going to be positive, this is going to be negative, and this is positive. So a negative over a positive is going to be negative, right? So to the left of -8, the function is going to be negative, so the original function should be decreasing. The derivative should be 0 at -8. So let's see what happens between -8 and 0. An easy number to test is 0. So if I plug 0 into the first derivative, the top is positive, the bottom is positive. Positive divided by positive is positive, right? So then the first derivative is going to be positive. Let me kind of generate some space here because I realize that this is a little bit jammed here. I'm going to just move this guy over a little bit and move you over, right? Just to create a little bit more space, okay? So to the left of -8, the first derivative is negative, so that implies the original function is decreasing. If we plug -8 into the first derivative, the answer is going to be 0. If we plug any number between -8 and 8, we should get a positive result, so that means the original function is increasing. And then to the right of 8, I'm just going to choose 10. If I plug 10 into the first derivative, let's see, like if I plug it in here, the numerator is going to be negative. This is going to be positive. A negative divided by positive is negative, right? All right, and this is kind of clean, so that makes it easy for us, right? So that implies, so if we go from decreasing to increasing, this is a relative minimum value here. If we go from increasing to decreasing, this is a relative maximum value here, right? So then we just need to find the corresponding y by plugging it into the original. So when x is -8, we're going to get a result, and when x is 8, we get a result, okay? So what I'm going to do, I'm going to plug into the original right there. If we plug in -8, we're going to get -8 divided by 64. Let me see, 64 and 64, 128. So -8 divided by 8. Let me see. Hey Siri, what's 64 plus 64?
64 plus 64 is 128.
Hey Siri, what's -8 divided by 128?
-8 divided by 128 is -0.0625.
Let me see something. I'm going to go hop over to Pearson, see how they want their result. Use integers or fractions. Okay, so if we have what, -8 over 128. I just want to simplify that. They're both, let me kind of come over to the side. Ugh, I think my stuff is slowing down. Negative 8 over 128. You can divide, you can factor out a 2. You will get negative 4 over what, 64? I think you can divide by 4. Negative 1 over, let me see, 6, how many 4s? That's a 1, 14, nope. So it's not even, but let's go back and do by 2. Okay. If we divide both by 2 or factor out a 2, what is that? 32? Is that right? Am I doing this right? 4, that's a 1. Oh, 24. Yeah. I just didn't do it right before. Okay. What do we get? 32? And then we could have did 4. 1 and what is that? 16? Okay, so negative 1 over 16. Okay. So that's the corresponding y. Okay. And then let me see, are we going to get the same thing when we plug in 8? It'll probably be positive though. Oh, it looks like we might have some symmetry. Maybe not. I don't know. Okay, so 8, I think it's going to be the same thing, but it should be a positive 1 over 16. Okay. Okay, so we should have a minimum value there, a max value there. Okay, let me highlight these. I'm just going to do something like, let's do like this. Because I'm just doing it this way, because like this is not our final answer, but this is like where we want to submit. I think I can go like this, and that'll make it more boxy. Okay, that's fine. Then let's copy. Let's paste. Okay, so these are the results that we got there. Okay, we're gonna let that be. So that was for part A. So we got a minimum value at negative 8, comma negative 1 over 16, and then we got that max. Okay, intervals over which is increasing, decreasing, or constant. Okay, so then part B, we still use the first derivative. And right here, that line graph, so it should be decreasing. So the original function should be decreasing from negative infinity up until negative 8. Also decreasing from 8 to infinity. And then the original function should be increasing between negative 8 and 8. Let me check the chat to see. Oh, I didn't realize you guys couldn't see. Okay. And let me see, home, yeah. Okay. Okay. So that was part B. So we found the intervals where the function should be increasing or decreasing or constant. Find the points of inflection. So the point of inflection, we need to look at the second derivative. So what I'm going to do, I'm going to take a copy of this guy here. Copy. Let me see my time. Okay, I think we're good. This is part C. Let me paste. Okay. So now let's look at the second derivative. G double prime. I guess we can use Lodi high, the quotient rule again. So the bottom, which is this, x squared plus 64 squared times the derivative of the top, it's just going to be negative 2x minus the top, which is this, times the derivative of the bottom. That's going to be a lot. Okay, so the bottom is going to be 2 times this. I think the exponent is subtracted by 1. Times the derivative of the inside is going to be times 2x. Okay, I'm going to get this all on one line, and then over the bottom squared. So that's going to become x squared plus 64 to the power of 4. Okay. Let me do the following. Let me think about it. I'm going to do it like this. Give me a moment because I'm just going to rearrange some stuff. I'm going to like shrink all this down. And then I want to put it where it belongs, like that belongs there. Okay. And I'll let that be for now. with OCD. Okay. And then let me put this where it belongs and expand it back. Okay. All right. Okay. Now on top, we can factor out. It looks like we have a 64 minus x. No, I was gonna say we got the x squared plus 64. We have that twice that we can factor out. Let me see. The bottom times the derivative of the top minus the top times the derivative of the bottom. Okay. So we can factor out x squared plus 64 from both terms on top. Okay. So then g double prime, let me do it like this so you can see it. So there's one here, and there is one here. Okay, like this. It's in blue, right? So both terms have that blue thing that we can factor out. So if we factor out that blue thing, we're going to have x squared plus 64, okay? And what we're going to be left with, we're still going to be left with at least one x squared plus 64 here. And then that's going to be times that negative 2x. That one is gone. We got this minus 64 minus x squared. And then times 4x. Okay. I know it's a little bit of much, but you know, you got to take your time and do your best. Okay. So then what happens is this cancels, this turns this 4 into a 3, right? That's what happens. So then we have g double prime. Let me check the chat. Okay. It's going to be now, if we keep going with the top, I guess we can go ahead and start distributing. So on top, we're going to have, I mean, we could have factored out, we could factor out a negative 2x. I mean, okay, to make it simple, to simplify it some, I'm going to factor out a negative 2x, right? And I'm going to show them here, like, well, I'm just going to do it. So if we factor out a negative 2x, that's going to leave us with x squared plus 64. That negative is gone. So a 2 persists there. Ooh. Hopefully I hadn't made any mistakes. This is very easy to make mistakes on this. So woo, we're going to have some fun. X squared plus 64, okay, to the power of 3. All right, we're almost there. G double prime, negative 2x. Let's see. That's going to be a negative 2x squared plus x is going to leave us with negative x squared. Okay. Negative x squared, and that's going to be a 128. Nope. 3 times 64. 180. 192, right? So it looks like we're going to have 192 minus x squared. Okay. I don't think 192 is a perfect square. What's 14 times 14? 4 times 4 is 6. 225. Hey Siri, what's 14 times 14?
14 times 14 is 196.
So it's not a perfect square, okay? I think we've addressed everything there, and I think this is what it boils down to. It's intense. You just got to take your time, space stuff out, look at it. If your head feels like it's about to implode, just walk away for a little bit. Step away from it for like a few minutes, go rest, play games, eat some food, take a nap, do some exercise, do something like that. And then take it. But I do the best when I first wake up, right? So I would step away, come back, and just, you got to take your time, okay? All right, so this is as far down as I could get it. I'm going to work with this and trust it, okay? All right, so now, the point of it, so again, hopefully this is correct. We could probably use some software or something to like spit this number. Like I know when I had I think I still do have that TI-89. I just got to go looking for it. But some devices can like crunch all this stuff for you. And I'm sure there's ways to do it online as well, but I'm just go with this for now. Okay, so the point of inflection is going to occur when the second derivative is either 0 or when it's undefined, right? So this is going to be 0 when the numerator is 0. So let's set the top to 0 and solve. So if we say negative 2x times this 192 minus x squared. If we set it to 0 and solve, because we have two or more things that multiply to give us 0, the zero factor property says negative 2x equals 0 or 192 minus x squared equals 0, right? So then the first one we get x equals 0 or x equals plus or minus, hopefully, I'm going to hop over to Pearson to see how they want that result. 192, 96. Let me see. Let me hop over to Pearson and see how they want this result. Use integers or fractions. Use a comma. I feel like we made a mistake somewhere. Okay, I'm gonna look at something else. Let me see. Hey Siri, what's 192 divided by 4?
192 divided by 4 is 48.
Hey Siri, what's 192 divided by 16?
192 divided by 16 is 12.
16 times 4. 40. 16 times 4 is 40 and 24. 64. Hey Siri, what's 192 divided by 64?
192 divided by 64 is 3.
So I was doing that because of the following. Plus or minus, this is 64 times 3. Square root of 64 is 8. But I still feel like something's not off. Something's off because maybe that's not going to be a point of inflection. Let me see. Let's because it has to change concavity. So maybe it doesn't change concavity at those points. Okay, so we need to test these results to see how they behave, right? So what we need to do, go to our number line, okay, and we need to plot these. Here's 0. We're going to let this be negative 8 times the square root of 3, and this is going to be positive 8 times the square root of 3. And what we need to look at, we got to look at the second derivative. The same way we did first derivative, we need to look at second derivative. And actually, we're not even done because, I was going to say we need to test the bottom, but actually, cube root, subtract, we get a negative 64. Yeah, this is never going to be 0, right? Because if you set it to 0 and solve, you take the cube root, you get x squared plus 64 equals 0. That's never going to be 0. So these are the candidates. Now we need to investigate how they behave in the second derivative, okay? If you're still hanging with me, you are a trooper because I know this is a lot, okay? So now, we're plugging these into the second derivative. When we plug 0 into the second derivative, these are going to be zeros. All of these should generate zeros, right? Now, let's look at the concavity. Negative 8 times the square root of 3. Let me see. Hey Siri, what's negative 8 times the square root of 3?
The answer is approximately negative 13.8564.
85. So this is approximately negative 13.8564, and this is a positive 13.8564, okay? So we can have a sense of what those numbers. So a number to the left would be like negative 14, right? So if we plug negative 14 into the second derivative, this term is going to be positive. 14 is 196. This is going to be negative. This is going to be positive. So ultimately, the second derivative should be negative over there, okay? Negative. So what that means is that the original function should be concave down. Okay, let's test something between these two. Let's do negative 10. If we plug negative 10 into the second derivative, that term is positive. Let me see, 100. This is going to be positive. This is going to be positive. Oh, that might be a point of inflection. It's making me nervous. Okay. I'm gonna go back. I got it because I feel like we made a mistake. I'm gonna do some investigating before I submit it. So we do have that's going to be a point of inflection. To the right of 0, I think if we plug in 10, and it looks like 0 is not a point of inflection. So it looks like we have 2 points of inflection. Between these two on the right here, I'm going to choose positive 10. We should get a similar result, right? Let's see what happens. This is going to be negative. This is going to be positive, so that's negative. Man, I'm nervous about this. We're gonna keep going with it because that's what we got. We got a negative result there. And then to the right of that, we can choose something like 14. So if we chose a positive 14, this is negative. Double negative is positive, and then positive. Okay, so we're gonna see. We got 1, 2, 3. We got that all three are points of inflection. Okay, so before I keep going, let me check. I want to check Pearson, and I want to kind of compare to the results that they got, just to see. And this one question is like eating up all of our time, but that's how it goes sometimes. Daggone it. And we don't get a viewing example with this one. So this one, we're gonna have to bite the bullet on this one, right? All right. So we're gonna have to go with what. Well, we don't have to. We're gonna do some stuff. So now let's hop back over. Let's just go with it for now. Okay. So we need to find the ordered pairs associated with these. I don't know. My intuition is feeling like we got something off, but I'm gonna go with it. Okay. So I just need a copy of the original. That's why I'm backing up right here. Right here. We're just gonna go with it for now. Let's copy. Okay, and we're gonna paste. Okay. So now, to find those corresponding Y values, I'm now going to just use my calculator because this is too much now. I was trying not to use it, but it's fine. Let me go ahead and mark those that aren't here. These, I haven't seen these guys. Okay. Let's hop over. Let's use the calculator right here. Okay, cool. Reload and refresh. All right. So I was trying to avoid the calculator, but I think we need to use it, all right? Okay, so the original, I'm going to go to my y equals. We got x divided by x squared plus 64, okay? Okay. And let's quit. Let's find the corresponding y values there. Let me see something. Yeah, because that's getting a little bit nasty. All right, so before I go forward here, what I'm going to do, I'm going to go to Pearson and start submitting some of my results to see how we've been doing so far. I know we hadn't finished. Let me get those decimals. I know I'm kind of second guessing, but we're close. Let's just go ahead and finish. So we're going to go variables, y variables, because we can actually check a lot of this before we submit anything. So when x, let me see, when x is negative 8 times the square root of 3, right? Okay, and the corresponding y value there is what I anticipated. Can we at least get a fraction? No. So I'm just going to go with the decimal. Let me see. If we were to do it by hand, 64 times 3. Yeah, I'm just going to write that decimal. So we get this negative 8 times the square root of 3, comma, this negative 0.05413, okay? I'm going to go with that when x is 0. Okay. The reason I kind of wanted to check some stuff before I kept going so we didn't waste a lot of time. Okay, so it looks like the origin might be something. And then I guess the other one should just be the same thing but positive. Let me just confirm. And this one with a positive. Okay, same thing, right? So we get this 8 times the square root of 3, and we get a positive 0.05413. Okay, I'm going to go with this. Now, we're saying that these three are points of inflection. We're going to just see how it behaves. We're going to see what happens. Let me see, concave down. Let me kind of put all this together. I'm going to attempt to graph this before I look at anything. Because let's just see how it unfolds. So what we're going to do, we're going to look at x versus g of x, right? And we're going to gather all those points that we found. So from part A, we said max and min. So let me get a copy of these guys. I want to copy. And we want to include those two in our table. Okay. All right. Okay. So we know like 0 is one of them. When x was -8, we got this -1 by 16. When x was 8, we got 1 by 16, okay? We got the origin was a point. We said this was a minimum value. Our claim is that this was a min. Our claim was that this was a max, okay? That was from part A. I'm gonna let that be for increasing, decreasing, and constant. Now for point of inflection, we got 3 points of inflection, okay? That was like 13 point something. So we got, move this down. We got this -8 times the square root of 3, and the corresponding y was this negative 0.05413. I'm going to label it as a point of inflection, okay? We also had a second point of inflection. Actually, this was also a point of inflection, okay? And we got this one, 8√3, not negative. Okay, we're going to look at the graph and try to do some investigating here. Point of inflection. Okay, let me see the time. All right. Now what we should do, we should find a few points between and beyond these, and I think I will. I'm just going to find a few. We're just going to find some x's and find the corresponding y's of a few additional points and see if it kind of comes together. Let's undo that. So I'm just making a little bit of space. Okay. So for instance, a few additional points. So if that's like -13, I can like let x be -15, find the corresponding y. I'm going to let x be -10, find the corresponding y. I'm going to let x be -5, find the corresponding y. And I'm going to do 5, 10, and 15, right? So then what I'm going to do there for those, I'm just going to hop to my calculator, okay? Because I'm trying not to look at the graph just yet. I want to see if we can put all this together. Okay, so for the few additional points, okay, come on. Okay. So now let's see. Let me just check real quick when x was 0. Okay, that's correct. Okay. So now let's see when x is -15. The corresponding y. Ooh, these are like nasty. All right. So we get the corresponding y is -0.0519. So it's kind of close, but that might be the case. And it's probably going to be similar for the others. If we do -10. Okay, we get -0.06. Let's just do 1, okay, for rounding. I'm just going to go ahead and do -5. Okay. We get -0.056. Let's do 5618. 5618, okay. And then it should be a repeat. Let's just without the negative sign. Delete. Okay, so then it should be, so it looks like we have some symmetry going on. 0.05618, and we could do a test for symmetry, but I think we've done enough with this one. 0609. Yeah, this is fine. 0061, and then 15 was 0.0519. Okay, are these numbers working out? Are they getting bigger? They should. That probably goes higher. Okay. So our y values are kind of tight in there, right? It looks like the y's, let me see. So our x's go from like -15 to 15. Y goes from like negative, we can almost go from like -0.1 up to +0.1. Okay, this looks weird. Let me see. Let me see if we have some symmetry. Let me do a quick test for symmetry. So right here. So what I'm going to do for that, this is just off of my own, g of negative x. It looks like it's odd, right? Because we can get, we should be able to get negative of the original, right? That means it has origin symmetry. And I think these numbers confirm that. Yeah, so we have origin symmetry. Okay. So if I did a rough sketch, right? If I were to do a rough sketch, say this were my origin, my x's would go to 15, my y value, it looks like we can go from like negative, honestly, 0.06. Let's just go from negative 1 to 1 and we'll break it up into like 4 parts, right? So we'll go like 1, 2, 3, 4. This will be like negative 1 here. I mean, that'll be 1 there, right? And then we can go 1, 2, 3, 4. This will be negative 1. Y's we need to go to like 15 or 20. Let's go, what if we went 2, 4, 6, 8? That's not right. 5, 10, 15, 20. 3, 6, 9. I guess we can go by fives. 5, 5, 10, 15, 20. Okay. And then we'll go 5, 10, 15, 20. Okay. So we're going to go like this. Come on. Undo. That's the positive x. This is the positive y. Okay. We said this was 5, 10, 15, 20. 5, 10, 15, and 20. Okay. This is a 0.5. This is 0.75. This is 0.25. Negative 0.25. It looks like I skipped some there. This is negative 0.5, negative 0.75. Okay, so let's try to plot these points. I'm going to plot them all in blue. So we do have the origin, right? When x is 5, we're at 0.05. So this is all really close. Like we might need to zoom in even more. I might have to change that scale. From 0 looks like we need to go to like 0.1. Let me change it. Okay, say this was 0.1. All right, 0.1. This is 0.05. This is 0.025, and this is 0.075. Okay, I think that might be a little bit better. We're almost there. I know it's intense. We're almost there. Okay. So then if this was 0.1, this would be, right here would be 0.05, 0.025, and 0.075. Okay, let's go with this. So now let's see if this works. So when we go over 5, we go up to 0.05, right? Over 5, so we would have a point here. If we go over 8, hey Siri, what's 1 divided by 16?
1 divided by 16
0.625.
is 0.0625.
0.625. So that's about, it's a little bit above. I just did it slightly above. 10.61, so that should be coming down. Was that a max? So this is a max here. Okay, that kind of confirms. So then the other one, let me see. That was 10. That one was like 13. I forgot that number. 13 something. So almost 14. So then that one is about here, and we go up to 0.05. So slightly below, right here. Okay. And then 15.519. And so that's like here, 5.1. Oh, I think I'm a little bit off. Okay. I think it needs to come up some. I'm going to move, let me see, 10 was 0.06. That's a max. So that might just need to be a little bit higher. So something like this, like about there. And then this one at the 14, that one needs to be like about here, something like that. And then the 15 was a little bit less than that. Okay, so then, you know, we have basically it's like flip top to bottom. It's the same points, but it's like here. So then this one is like here. We got 8, and that's like a min. So that one was about here. I'm trying to match it up. About here. Then we have 10. 10 went to 0.5, which is here. And the last one, I'm just ballparking it. Let's look about here. Okay, so it looks like, all right, so now this is the raw analysis. Now, going off to the left, I mean, the raw analysis is something kind of like this. Yeah, I got something kind of like that. Okay, so now that's like what I know that was intense. That's not looking at any graphs or anything. Now let's actually look at some graphs, right? So if we turn the calculator back on, we have the original there. Okay. So I'm going to do a window that's similar to what we have here. I'm going to go to window, my X minimum. I want to go down to -20. I want to go up to 20. And then we can go by 5s on the X axis. The Y minimum, it looks like we need to go down. Let's go down to like -0.1. Okay. Let's go up to 0.1. And let's kind of match ours. Let me see. 0.05, so 0.025. 0.025, okay? All right, let's cross our fingers and see what do we get. Man, oh man, right? So that's reassuring. Oh, that was intense. I ain't gonna lie, but you see, we did all of it by hand. I didn't look at any graphs, and that's intense. That's a lot. I'm not gonna lie, but you know, but the concept still hold. And I was even second guessing myself. I was like, this looks weird, right? But you see, it actually panned out. You know, it got nasty. I ain't gonna lie, it got nasty. But it's all correct. Like between the max and the min values and our points of inflection, they look like they work. Because there's that one. Yeah. Okay. So I know that was intense. It took us like forever in a day. Let me hop over to Pearson and let's see if we can get this correct. So I'm confident in our results. I know it was an adventure. I'm confident in our results. So now I'm going to hop over to Pearson. Is it still working? Oh, come on. This technology is driving me nuts. All right. Hopefully Pearson has not like crashed on me. And I don't want to restart it. Come on. Oh. All right. So I'm going to close this window. Hopefully we get the same question. So I'm going to have to hop back to Pearson and like, we're just going to have to like probably just take what we got. Let me go like this. I'm going to have to reopen it. So let's go to my lab and mastering. Come on. And if we're lucky, we get the exact same question. If we're not lucky, then we're just going to have to trust what we got. Like that's because you know you want to get that confirmation from Pearson, but you know sometimes it just don't work out like that. I got to log back in. Man, I feel good though. I feel good that like it actually came together. I was like, because I was like, no, my work feels. I feel good about the work. Come on. I'm just trying to load the example back. Hopefully, we get the same question. So we're gonna be at the mercy of the RNG. Okay, let's see. We're working this one. And you know, all of them are not like that. I don't know why. I mean, it does have that potential. And you know, I know it's kind of like a bit much to ask you not to be intimidated by that because that is intimidating. But they aren't all like that. Let me see this one. Is this? I think it's the same. Let me check. Just want to see my original. right here. X over x squared plus. Okay, you know what I can do? It's not the same. What I'm gonna do, I'm gonna just leave and come back and see if I can like get the RNG to produce the same question. So like if I exit out and come back, let's see if we can get back to one that has a 64 there, and then we'll work that one. Because if it can change it away, that means it could change it back. Come on, I need you to change it back though. I'll try a couple of more times. It's not changing now. Okay, let's do like this. And we're gonna go back to this is week 5. Because I wanna see if we I mean, I'm confident in it, but I wanna see it like and this will be it. Like we're at the end for today. Oh, come on. You tripping. Maybe and I'm sure it was not 4 the whole time. Okay, let me go back. Maybe if I choose like 6 instead of 7. Because like now it's not changing the number and we did too much work to not be able to submit it. Let's go to 7. Oh, dang. Okay, let me hit I don't want to hit save. Okay, you know what? I think I logged out last time, so I'm gonna just do that again. We still got like give me like 10 more minutes. I'm not gonna keep you much longer, but I'm just trying to pull back the very same question that we were working on with the same number so we can submit our results. Okay, let's go to calculus. Because you don't want to do all that and not know if it's right or not, right? You know what I mean? You want to check it. Week 5. Here it is. This one. Question 7. Come on, 64. You know you want to show 64. What we got? Heck on it. It's not changing now. It keeps showing 4. Oh, you suck. You suck, Pearson. I'm gonna try one more time. I'm gonna log out. I'm gonna do a new. I'm gonna just try a couple more times. I mean, what we could do. I'm not about to go and do that with a 6 instead of 64. Unless I mean, it could have been 4 the whole time, but I don't think it was. But Pearson is infamous for like stuff like that. Like you do all this work and then you go to submit it, and now the question it like locks up and freezes, and then it changes the question. You're like, no. And like now it's not changing at all. So that's the frustrating part. Like if at least it was changing, I would feel better. Let's go here. Oh, you know what? I can try a similar question too. That's another technique. So if it doesn't want to change here, what I'll do is I'll just push it to the end, and then I'll just try a similar question. Let me see if that works. So let me see. I'm gonna make this full screen. I know you guys can't see it just yet. I'm still trying to pull up our question. Can I just submit it? Blah, blah, blah. Check the answer. Check the answer. Final check. Hopefully I didn't write the original wrong. Check. Give me just like a couple more minutes. Because I don't want to just like take my word for it. I'm trying to pull up another version. Final check. Come on. Check the answer. I got 2 parts remaining. Just give me a moment. Final check. Okay. And then one more. Okay. All right. So I'm just trying to like hopefully we can get the numbers to change. I'm gonna hit similar question and cross my fingers. Come on. Yeah, we got the graph. We got all that. Yeah, okay, so I'm looking at some of the results. Okay, no, I don't want now. So what we did was correct. I'm just trying to check our numbers. 49. Okay. I got that to change. Let me close this out. Let me close this out. All right, I'm probably going to let you guys go. And I think what we did is correct. This is going to be my last try. If I don't get it, if it doesn't show it this time, because the numbers did change, but it showed 49 and not 64. So I'm just going to try one more time. This. I think another thing, like when I'm working questions like that, if I find myself getting away from it for a long time, I got to hit save. If I hit save, it should give me the same number, right? And not be switching it up. Come on. And it's like, it always does what you don't want it to do. Now it's back to 4. Oh, maybe if I hit similar question. Let me hit similar question. Let's see what happens. Okay, okay, that's promising. Hang on, hang on. Let me try it again, because now I think the similar question is actually working. I might do a little bit of a bonus stream today. I'll let you go. I'm watching the clock, so I'm not going to keep you past. Okay, and then similar question. All right, we are in business. We finally got it. Okay, so let me. I think that's showing there. So let me make this full screen. Let me do a new share so you guys can see it. We got that one, and we want this one. Okay. All right. So if you know, feel free to leave whenever, because I get it. I'm watching the clock. Finally got back to 64, so we're just gonna check that number, right? So all the questions were the same, and our work was actually decent. Like when I looked at some of the stuff, it was very similar to what we have. Now we're just trying to confirm some numbers, right? And the only thing that was changing was this 64, but everything was the same, right? So we're just gonna try to submit the answers that we got. Okay. So it says the relative minimum points and max, right? We got those, and it says integers or fractions, type in ordered pair. Okay. So the relative minimum that we got, that was an adventure. -8, -8, comma, -1/16. Okay. And then the max, I'm watching the clock because I know we're at that time. Parentheses. But it's good that we have this experience, so I have a sense of what you guys are going through, and it helps me to be a lot more understanding, like patient, because I know it's a challenge, and I know it is, and it's not your fault, So if I'm having those issues, then I can imagine, you're in. Okay, so that was correct. Increasing, decreasing, and constant. Okay, so we got that it's decreasing. Let's see, we got that it's increasing between -8 and 8. We got -8 and 8. And we got that it's decreasing. All right. From -infinity up until -8. And it's also decreasing from 8 to infinity. 8 to infinity. Okay. Let's check this answer. So it's looking good. I'm watching the clock. We're almost done. I'm about to let you guys go if you haven't left already. And just work. Let me see. What are the and I'm gonna we can get through this. What are the coordinates of the inflection points? So the inflection point. Now let's see. Order pair and exact answer using radicals as needed. And I think that's what we got. That's what I was looking for. And that's reassuring, right? So the only thing is the y value. So all right, we need to go back and find those y values. Okay. All right. So let me see the y values. I'm just going to work it and not show it. It's right here. Okay, I'm going to add a page. Let me just work it out real quick. See how quickly I can do this. Okay. So now I think when we get one, we'll get the other. I'm going to do this in orange. So that's the original. And we got this. Okay, so if we did So if we say g of 8 root 3, right? That's going to give us 8 root 3 over 8 root 3 quantity squared plus 64, okay? But then that's going to be 8 times 8 is 64 times 3, so that's going to be 64 times 3 plus 64 over 8 root 3, okay? So then that becomes whatever 64 times 4 is, right? Hey Siri, what's 64 times 4?
64 times
256.
4 is 256.
8 root 3 over 256. Hey Siri, what's 256 divided by 8?
256 divided by 8 is 32.
So we get the square root of 3 over 32. Okay, so that's all we needed. Okay, that's not too terribly bad. Again, once we got that confirmation, then I was able to kind of take it. So points of inflection that we got, the exact results look like they are negative 8 times, nope, negative 8 times the square root of 3. And then the corresponding y was negative square root of 3 divided by 32. Okay. And then we also get what? The origin. So we got the origin was a point of inflection. So 0, 0. And we got 8 times the square root of 3, comma, square root of 3 over 32. Okay. All right. Yeah, I'm going to go with that. I see the time. About to get you guys out of here. Awesome sauce. That's what I needed a confirmation on, because I was like, man, we worked too hard to not get there. We didn't come that far to, fall short. Concave up and concave down. So just following, I guess I can get rid of that page. Let me shrink this down. I'm about to get you guys out of here. That's fine. And then this paper, let me get rid of this page. I can delete this. And we want the points of inflection. There they are. Okay. Concave down, right? Okay. So here it is. It's concave up. It's concave up from parentheses. I'm about to let you go. Negative infinity. It's concave up, sorry. Concave up from negative 8 root 3. 8 times the square root of, dang, I'm not typing my 8s. 8 times the square root of 3 up until that value we just found was root 3 over 32. Square root of 3 over 32. Okay, we got concave up there. And also from, wait a minute, I'm not doing this right. From that x value up until 0. Okay, so that's the first interval. And then the second interval goes from 8 root 3 to infinity. 8 times the square root of 3 up until infinity. I see the time. I'm getting you guys out of here. And then it's concave down. Come on. From parentheses negative infinity up until negative 8 root 3, square root of 3, and then 0 to 8 root 3. Zero to 8 times the square root of 3. Okay. I think that's okay. I'm going to go with that. Man, what an adventure. I see the time. We're a little bit over. The correct graph, we got, I think we got this one over here, D. Okay. All right. All right, guys. So you were a trooper, okay? I think we at least got our credit. So what we did was correct, and that's eye-opening. Like, that's intense, right? But I mean, you saw what it takes. So you just got to take your time, breathe. This is why I try to get stuff up early. Link up with the tutors, work together, ask me questions. Just do your best, okay? Just push. You get unlimited attempts. Just take a deep breath, get help, get it in, okay? I totally understand. Okay, and so let's hop back over to Pearson. No closing remarks. Let me actually, I'm gonna show this for the people at home. I'm gonna go ahead and push these notes that I took, so you guys can have a copy of it. Undo. Let me share. I'm gonna send it to Box, not that folder. This one, notes. I think it's this. Note back. This one. Send it there. Send it to Box. Okay. So a copy is being pushed to Box as we speak. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.
This class